We've got a log here from sleipnier1411 asking about oscillation on hard turns, and we'll take a look at that. But before I got into your logs, I just took a look at your PID parameters, just to sort of give them a sanity check. And nothing really jumps out, except I do see that you've got D-term cut set at 30, and that is going to affect the ability of the copter to, or the flight controller, to handle things like prop wash oscillation. The lower the cutoff frequency on your D-term, the more phase delay there is on the D-term. And one of the things that we've learned from Betaflight V2 is that there seems to be a substantial advantage to having the D term close in phase to the P term. In other words, not creating additional delay on the D term. So we'll see if that's what's going on here. But unless you had a very good reason for lowering D term cut to 30, then I certainly would consider putting that back at 40, which is the default. Okay, so that does stand out. I also see that we've got a TPA breakpoint of 1550 and a TPA of 20%. I think that's not going to be relevant, but we'll take a look at that as well. So here's your video, and actually I've got it queued up to a point right about where I think an oscillation happens. Let's take a look. So we've got a little bit of oscillation there. We can kind of hear it as you do that sharp turn. And the first thing we can ask is whether that is something that we could be dealing with TPA. And we can see that at the point where that turn is happening, your throttle's at about 1500. So probably not, because, I mean, if we just go through your video, there's another, that was a great one. We'll stick to that one. If we go through your video, we can see your throttle is often in that range of about 1500 to 1600. That's often where you're cruising. So if that's where you're cruising, then probably you should be tuning for that with little or no TPA, and then tuning TPA for the higher throttle positions. So in general, my philosophy is that wherever my throttle is normally at when I'm cruising, I want my TPA breakpoint to be about there or maybe a little higher. And I don't want to be setting my TPA breakpoint down here and then having to tune TPA and my PIDs here. There's no sense tuning for a low throttle position if you're never really going to be there. So tune your base PIDs for wherever you're normally cruising, and then if you need to, add TPA to lower them as the throttle gets higher. So this is not something that we're going to be tuning with TPA, because we can see that it's happening at the normal throttle range where you're normally flying anyway. So we need to just tune it out without relying on TPA. Now we definitely can see that we've got this oscillation. Again, I'll go back and play it. You can definitely hear it. And I want to reiterate here, listening to the motors is one of the best ways to find these oscillations. If your motors sound smooth, then you may still be a little overtuned. There's a gray area where you're getting small oscillations that may show up in the camera, but you may not be able to quite hear them, but you can see them in Blackbox. And then there's a point where you cross the line into definitely overtuned, and you can start hearing it in the motors. I say definitely overtuned, but I mean, some people like a really sharply tuned copter, and if you do, and you want to accept some prop wash oscillation, obviously that's fine, that's your call. But we can definitely see right here those oscillations, and we can see because of the throttle position where they're happening is pretty close to your normal throttle position, we're probably not going to solve this with TPA. Okay, so what axis are they happening on? Well, they're not happening on yaw, and they almost never do. They primarily seem to be happening on roll and a little bit on pitch. It's on both of those axes, but roll and pitch. It's very common to see on a mini quad that we get far more oscillation on roll than on pitch, and that's because of the weight distribution of the copter. The weight is more spread out on the pitch, front to back, and it is more centralized side to side. So the copter has less sort of inherent dampening in the pitch axis or on the roll axis than on the pitch axis. So let's look at the roll axis first, since that's where this tends to be the worst. And by the way, you said in your post, uh, seeing huge amplitude on the graph. I'm not 100% sure what you're talking about there. I mean, we are seeing some activity here, but I'm not sure that there's nothing abnormal about the graph, you know. It's being scaled to, I'm not sure what you're talking about there, so maybe you could clarify. All right, so then where's the point? What are we seeing here on roll? Well, the story gets more interesting, doesn't it? Because if we look at the roll axis here, boy, the first thing I notice is that the P and the D term are going crazy the whole time. The whole time. And especially the D term. Now, it certainly is worth thinking about whether, if you're not logging one-to-one, whether some of this might be aliasing noise, but it doesn't feel that way to me. Because it's just sort of present at all frequencies, whereas aliasing noise would be present at a specific frequency, usually. And especially as here, for example, right in that turn, we can see that we've got this oscillation, and it's manifesting in the P and the D term. So, but it's not just in the turn, is it? Because if I turn our playback speed down, now here, I would not have said it sounded like your motors were oscillating. They sound reasonably smooth to me. Some of that is because they're spinning really fast, so it's hard to pick out the oscillations. But we can clearly see here in the black box that your P term is constantly oscillating. Constantly. Constantly. All the time. Constantly. So this is bad. I don't want to see this myself. I wouldn't like this if it was my copter. So one thing I see here is that the P term is constantly oscillating, and it's reasonably strong and consistent oscillations. I mean, the P term is always going to move around, right? It's never going to be stationary on a dynamic system like a copter, because the copter's moving and the wind is blowing and et cetera, et cetera. But this is too much activity on the P term for me. So I think that the roll P needs to come down. Um, yeah, I think roll P needs to come down. The other thing I see is that during these normal flight, so this is just forward flight. This is not a very dynamic situation. I see that your D term is pretty consistently maybe twice the magnitude, half again, or maybe twice the magnitude of your P term. And that to me feels like too much D gain. So the first thing I would do is when we look at this scenario with this prop wash oscillation here in your sharp turns, that might get fixed by changing the D term cut to 40. It might not. But the next thing I would do, whether you decide to change the D term cut or not, that's your call. But the next thing I would do is I would start dropping the P gain on roll and I would take D down sort of out of the picture for a minute, just so it's not screwing up our analysis. So your D right now is at roll is at only 26, which is not terribly high, frankly, but it sure is active. So maybe that having a little bit too high P is resulting in D being overactive. I think if I were tuning this, I would want to be sure that D was out of the picture while I finished tuning P. And so I would set D to something like maybe 18 or 20 and really just lower it down, maybe even 15, and just really get it down so we know that the D is not really throwing our numbers off. And then tune P so that these oscillations soften up a little bit. In a forward flight like this, where it's just reasonably straightforward flight, and again, I'll play it. See, we just shouldn't see this much activity on the P term in flight like that. And then we end up, and here we've got a pretty big oscillation here on P. Yeah, constant. You see, it's just constant. The P term is constantly oscillating. That's too much P gain. And then here we get another turn with P oscillation, right? It's all the time, all the time. The P term never settles down, even during relatively stable flight conditions. It never settles down. And now look at this during this roll. Okay, so now we're looking at this roll, and let me just turn off the I and the D, and I gotta turn off the gyro too. Look what the P term does during this roll. We see this strong push into the move, like normal, and then ringing, ring, 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 right here. This is excess P gain, absolutely right here, excess P gain. Okay, these spikes, see how they're cyclical? They're relatively consistent in their frequency. In other words, the spacing between them is relatively consistent, and they're sort of following a path here, right? Yeah, this is too much P gain on roll. Let's take a look at your pitch axis, and we may see the same thing. So if we look at the pitch axis, the P term is still fairly active. Yeah, see here, this kind of regular pattern here. What are we doing here? We're turning. Now we're flying reasonably straight. You may have too much on pitch as well. This kind of regular pattern here strikes me as it's relatively high frequency in terms of the spacing between the peaks is relatively close together. It feels like too much pitch P gain as well, and possibly D gain as well. So yeah, here's what I would suggest. Take your D terms down to, let's say 15. That's certainly too low. You'll bring those back up later. But for now, take your D terms down to 15 on pitch and roll, and then start lowering your P gain a little bit at a time, maybe 0.1 at a time, maybe 0.2 at a time, just to find the area where these on Blackbox, these traces kind of settle down just a little bit, especially on roll. Pitch, you could convince me that pitch was okay, but on roll, I'm really confident that your P gain is too high, just based on what I'm seeing. Pitch could be on the edge of it could be sharply tuned, but not overtuned. Yeah, see, in a scenario like this is kind of problematic. We got spike, 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 spike. That's problematic. If we look at what you're doing here, see, there's just, okay, that's prop wash, maybe. Feels a little overtuned, though. I wish I could find a flip, but I don't see one. Is there a flip in here? I don't think so. Well, anyway, if there is, I missed it. Okay, so that's my suggestion. Hope that's helpful, and happy flying.